Why, hello! Today we're going to be looking at Notes 3-5, Three Variable Systems Elimination. So use elimination to solve the following system. You'll notice this is a three-variable system, hence we have three equations. I've labeled them 1, 2, and 3. So step number 1 is to pair two different sets of equations to eliminate one variable. So looking at my variables here, looking at my x's, looking at my y's, and looking at my z's, I see that it would probably be easiest to eliminate my z variable because if you notice, none of them have coefficients other than 1 and -1. So that's going to be easy. So what this means here is I'm going to pair up, I just pick 2 twice. So I'm going to pick 1 and 2 first because if I pair 1 and 2 up and I add them together, these two are going to eliminate. So let's go ahead and pair 2x minus y plus z equals 4. So equation number 1 with equation number 2. X plus 3y minus z equals 11. So that's equation 1 with equation 2. So if I use elimination, what's going to happen when I add these, that becomes 3x, that becomes 2y, and those cancel, very nice, equals 15. Okay, so now I have to pick another set of 2. So I've already done 1 and 2, so obviously I'm going to have to repeat 1. Now let me go ahead and do 2 and 3. Okay, it doesn't matter which other 2 you choose as long as it's not the same as these and as long as you include 3. So I'm just going to go ahead and choose 2 and 3, so equation number 2 and equation number 3. So what happens if I pair those two? X plus 3y minus z equals 11, and then 4x plus y minus z equals 14. Well, if I go to add these, are my z's going to eliminate? No, and if I eliminated the z's in this set, I've got to eliminate z's in this one. Whatever you eliminate in one, you've got to eliminate in the other. So I'm looking to eliminate z. So that means I need to multiply either the top or the bottom by -1. Okay, so let's see. I'll just go ahead and multiply the bottom by -1. So I'm going to keep the top the same. X plus 3y minus z equals 11. And then this will turn to -4x minus y plus z equals -14. Okay, now when I go to add, that would be -3x plus 2y, the z's eliminate, equals -3. Okay, so you're going to go ahead and label your two new equations. So if that's 1, 2, and 3, then we'll call this equation number 4, and we'll call this equation number 5. Okay, because step two is that you'll write the two new equations as a system and solve. So now this goes back to what we've been doing, goes back to Algebra 1. So I've got two new equations here, 4 and 5. So 3x plus 2y equals 15, and -3x plus 2y equals -3. So, and we really get lucky with these two because, look, if I go to use elimination on this, what happens? If I add these two equations up, 3x and -3x, that's going to cancel. I get 4y equals 12. And then I can solve for y. So I know if I divide by 3, divide by 4, I would get 3. So y equals 3. So I've solved one of my variables, and that's very exciting. So now that I've solved for 1, my step 3 is to plug answer into one of the new equations. So either 4 or 5, one of the new equations. Because if I plug it into the original equation, if I plug in for y, that's fine and dandy, but I'm still going to have x and z. I'm not going to be able to solve for 1. But if I take this y and I plug it into one of the two of these, I will be able to solve for x because there is no z. So just for the sake of ease, I'll pick the first one. So I've got 3x plus 2 Where I see y, I'm plugging in 3 equals 15. So then go ahead and solve for x. So this would be 3x plus 6 equals 15. Subtract 6 from both sides, I get 3x equals 9. So when I divide by 3, I know I would get x equals 3. I've got another variable. That's very exciting. So last but not least, yay, step 4, plug both answers. Now we can go back into the original original equation and solve for that third variable. Okay, so it doesn't matter which original equation I look at. It could be any of the three. So going back up to one of the original three, I'll just pick probably, I'll pick 2. I'll pick 2 because it's got the lowest coefficients, pretty much. Okay, so 2 would be x, which is 3, plus 3y, which y is 3, minus z equals 11. So I picked equation number 2 to plug in what I know for x and what I know for y. And so now I'm going to solve 3 plus 9 minus z equals 11. So I can combine the 3 and 9 to give me 12. So 12 minus z equals 11. When I subtract 12 from both sides, I would get negative z equals negative 1. And when I divide by negative 1, I would get z equals 1. So how you write your final answer for this is a system of 3 variables. It's a coordinate triple. So not a coordinate pair, but a coordinate triple. So x is 3, y is also 3, and then z is 1. So there is your place of intersection.